Awesome. Is my screen visible?
Yes, ma'am.
Okay, great. So I thought we could start off today's session with some interesting problem in coloring and then go into some very interesting game. Okay. So the first question that we'll be solving today is so does everybody here know what a plane is in geometry? A plane is just something that extends in all it's just something that is flat. So you can imagine it as a piece of paper, but it's an infinite piece of paper. You can go in any direction for as long as you want. That's what a plane is. That's how you can imagine it. So now what we want to do is we color the plane, or let's say we color every point in the plane in two colors. Say red and blue. Okay, let's be more precise. In one of the two colors, red and blue. What does this mean? You give me any point on the plane, and it's either going to be red or it's going to be blue. Okay. And what do we want to prove? Prove that there exists two monochromatic points which are 5.139 centimeters apart. Now let me explain the question. What does monochromatic mean? Monochromatic just means something that is of the same color. So two monochromatic points just means 2 points that are the same color. So I'll repeat the question again for people who recently joined. We're coloring every single point in the plane in two colors, either red or blue. Now we want to prove that there exist 2 points. Monochromatic just means points which are of the same color. Two monochromatic points, so 2 points of the same color, which are at a distance of 5.139 centimeters. How could we go about proving this?
Ma'am, I have a question.
Yeah.
What do we define as a point in a plane? Like there are infinitely many points.
Yeah. So wait, let me finish answering this question, then whoever spoke, I'll come to you. So that's exactly right. We have infinitely many points in the, which means that for every single point, we are going to decide a color for it. Let's say this point, let's say we want it to be, let me just switch this to blue. Yeah, let's say this point we decided to be blue. Let's say then there's a point just below it. Let's say I want it to be red. Then I want this point to be also red and then red and then red. I want this point to be blue. And so just I continue like this. And the entire plane, the entire infinite plane is covered so that uh, we have each point is either red or blue. This fine, Dashraj?
But then isn't the question obvious? Like,
How? Okay, great. How? Why is it obvious?
if we like color a point blue and then if we color another point just next to it blue, then that will mean we have already proved. And if we color the next point as red, and then again if we color a point close to it as red, then again we are done. So if we color
Okay.
blue,
What do you mean close to it?
like
So,
just
what do we want to prove? We want to show that there are two red points or there are two blue points, which are five, so that the distance between them is 5.139 centimeters.
Ma'am, can I tell?
No, let me finish my conversation with Dashraj and come to you, Purna.
Yes, ma'am, I understand.
Okay. Okay, good. Great question.
Ma'am, but even I didn't understand the fact that like if I have two blue points which are 5.13 centimeters apart, and then I have any colors in between, won't it answer the question?
Yeah, so then we'd be done. That's what you want to prove, that no matter how we color the plane, we will always be able to find two red points or two blue points, which are at a distance of 5.139 centimeters.
Oh, okay, now I got it.
Right. So let me also.
Good afternoon, ma'am.
Good afternoon, Aitreya. To prove that no matter how we color the plane, so if there are people who recently joined, I'm going to repeat the question one last time. So every point in the plane is colored. So what is a plane? You can imagine a plane as an infinite piece of paper. It extends on all sides infinitely. Now it's made up of a lot of points. We're coloring every single point. It's going to be either red or blue. So prove that no matter how we color, no matter how we color the plane, there are going to be two points. What does monochromatic mean? Monochromatic just means of the same color. So prove that there are going to be two monochromatic points, 2 points of the same color, which are at a distance of 5.139 centimeters. This is the question that we are trying to.
But
Yeah.
how do we color a point? Like a point does not have any width or breadth or anything.
Okay, now we're being too technical, and these are good questions, but just imagine that we have this power that, okay, we just look at, there are so many points, we look at one point, and I asked you, that's trust, do you want this point to be red or blue? And we assign that color to that point. Then again, we just do this for every single point. Or you can also think of it this way, that we are just coloring the plane in two colors. So we have, okay, this part is going to be red, this part is going to be, oh sorry, this part is going to be blue, this part is going to be red, this part is going to be blue, this part is going to be red. We can just sort of assign colors in this way.
Okay.
Right?
Yeah. I just came
So-
I reached home late, ma'am. Is this a first problem?
Yes, it is. And I'll also just write down the second problem for people who are done with this one. So, okay. So I'm going to wait another minute or two. If you guys, somebody who hasn't solved this problem, entirely solved this problem, I want those people to speak. If you guys want to give any ideas about how we could go about solving this problem. Johan, if you're saying something, you're not audible.
I have the solution. I have a solution.
Okay, then I will encourage you not to speak.
Okay.
Try the second problem.
Ma'am, what is the plane here, ma'am?
A plane is just, for now, I don't want to get into the details, but a plane, think of a plane as an infinite piece of paper which extends in all directions.
Infinite two-dimensional paper.
Yeah.
Okay.
Excuse me, ma'am.
Yes, Akhil?
Ma'am, I came right now. So could you please, ma'am, I was not on. Could you please tell now? What did we do?
Yes. Yes, so we are trying to solve this first question. I'm going to repeat it for one last time. people's China time. We color every single point in the plane in one of the two colors. So, what is a plane? A plane, think of a plane as just as an infinite piece of paper. It extends in all directions. And so there are lots and lots of points on it, right? So we're just coloring every single point, either red or blue. And now what we want to prove is that no matter how you color, I'm saying that I will always be able to find 2 points. What does monochromatic mean? Monochromatic just means of the same color. So there will always be some 2 points somewhere which are a distance of 5.139 centimeters apart.
Okay.
We can also make this more interesting. Today is 26/11/2023. So I'll say 26/11.2023 centimeters.
Yes, ma'am. Means that we have to write everything, right? We have to prove that.
Yes, no matter how you color, there will always be some 2 points, which are centimeters.
Okay. Thank you.
Excuse me, ma'am. I just joined. Can you please repeat the question?
Wow, I am tired of repeating the question, but okay. This is actually the last time I'm repeating this. Have you read it on the board?
Yes, ma'am, but I didn't really understand.
Okay, so what is a plane? Think of a plane just as a two-dimensional, as an infinite piece of paper. That's all a plane is. And now you're coloring every single point on it. It's going to be either red or blue. Now, what you want to show is that no matter how we color the plane, there are just two monochromatic points, which are this much centimeter apart, 22,611. No matter how you color the plane, I will always be able to find 2 points that are the same color, monochromatic means the same color, which are,
Ma'am, that's
yeah.
today's date.
Yeah?
That's today's date.
Yeah.
Ma'am, what is monochromatic point?
Monochromatic just means points of the same color.
Oh, okay. Thank you.
No idea.
Ma'am, is it like we color the whole paper with only one color or with parts like red and blue?
Say that again.
Ma'am, is it like we color the plane in only one color or in parts of red and blue?
No, we are coloring it in two colors. So we are using two colors to color the plane, red and blue.
Means
But if
like
you want,
means like we have some parts of red and some parts of blue mixed together, like anywhere.
yeah.
Okay.
So any ideas from somebody who's not Chinmay or Johan? Or somebody who hasn't already solved it?
Mom, can I tell?
Who is this?
Shivan?
Oh no,
Shivanshu.
Shivant, I think you already also solved.
Ma'am, can I tell?
Okay, yes. What is, just give an idea. If you have the entire, don't give it away.
Uh,
How do we start?
I think we should use pigeonhole principle, but I'm not sure
Okay.
how.
That's an interesting start. Okay. Hmm. So why don't we do this? Let's say that I'm lying, and let's say that there is some coloring in which no matter okay, so let's just do this for let's solve this for 5 centimeters, and then you'll see that it's easily generalizable to any length you want. Okay, awesome. So uh let's say that there is some coloring which does not no matter which 2 points you take, which are 5 centimeter distance away, they're always going to be of different colors, right? So if I take this point, let's say it's red, then if I take up another point which is 5 centimeter away, it has to be blue, right? If I take another point which is 5 centimeter away, it has to be red. So what I'm saying is, what am I saying? I'm saying, let us assume that the given statement is not true. Let us assume that there is some coloring which does not satisfy the given state, right? Which means that no matter which 2 points you take, which are no matter which 2 points which are at a distance of 5 centimeter apart you take, they have to be of different colors. Okay. Now can we go somewhere from here?
Ma'am, is it compulsory to use only one color or both of the color?
No, but what do we have to prove? We have to prove that no matter how we color, which means that you have to show that for all possible colorings, this is going to hold. Do you
Yes, ma'am.
understand the power of the statement? Yeah. So let's say you prove, let's say you prove the statement that if I color the entire plane with just red, it's easy to see that obviously we'll have 2 points which are red, just 5 centimeter apart. But that is not enough. The question is saying something much more powerful. It's saying that no matter what way you color the plane in, take any coloring, you'll always find 5 centimeter monochromatic points which are 5 centimeter apart.
Yes, ma'am.
So what you're saying right now is okay. Let's say that somebody somehow is able to come up with a coloring in which no matter how you take, no matter which 2 points that 5 centimeter apart you take, they are of a different color. So if
Ma'am, if
this
we
point
color
is red,
the whole plane same color, like if we color the whole plane red, then we would not have 2 points which are of different color at 5 centimeters apart, right?
no. What do you want to prove? You want to prove monochromatic, which means points of the same color.
Same color.
So we would have this, right? This
Yes,
would be
ma'am.
satisfied because literally every point is red. Yeah. Okay. Okay. So let's say this is red and this is blue. Then okay, if let's say this point is red, then what does that tell us? Then every single point which is at a distance of 5 centimeters should be blue, right? Because if it is not blue, let's say there's some point here, let's say, and it's red, then we'll be done, right? What if we consider an equilateral triangle with side length 5 centimeters? So consider this, and this is an equilateral triangle where each side is of length 5 centimeters. What can we say from here? Can somebody tell?
Yeah. Ma'am,
Okay, I want somebody who hasn't solved this. I know Chinmay have solved this, so I'm just waiting for somebody who hasn't solved this to speak up. And also, hopefully, somebody who doesn't speak that much.
ma'am, I think this is related somewhat like between two girls, one boy. That problem.
Okay. Well, it's not that hard at all. It's not that hard. It's kind of easy from here. We have 3 points, and each pair is at a distance of 5 centimeters.
Oh, so no matter which point you'll take, like if you have only two colors, and no matter wherever you place, the two colors are like adjacent. Suppose you place yellow here, and then we place green here, then we have to place yellow here. We have consecutive colors.
Right. So let's make that argument more formal. Since we have only 2 colors and we have, okay, Chinmay, do you want to add anything to this?
No, ma'am.
Okay, great. So since we have only 2 colors, but we have 3 points, no matter how we color these 3 points, we're going to have the fact that some 2 of them have to be of the same color, right? Let's say this one is red, let's say this one is blue. So if this is red, we will have this and we'll be done. If this is blue, then we will have this, these two will be blue and we'll be done, right? So no matter what we color this point with, we are done. Please don't annotate.
Sorry.
Thank you.
Okay, ma'am.
Yeah, Shivans, do you want to add something to this?
Yes, ma'am. I have a generalization. So, like,
Okay.
if you have n number of color, you have to take a polygon with n plus 1 sides. Each side equal
Ah,
to should be the difference between the two
No,
like
ma'am.
points.
Ma'am, I think it would be wrong because then in
okay, first of all, wait, Chinmay, I really want you to talk about this, but let me just explain what Shivans has said. So Shivans is saying that let's say we have 4 colors, right? Then we can easily, then what do? Then we can still show that we'll have 2 points which are at a distance of 5 centimeters because we can consider a polygon with 5. So we can consider a pentagon. Just assume that this is a regular pentagon, which means, okay, let me scroll down. Yeah. We can have a very symmetric pentagon with all equal sides and equal angles, right?
Miss,
It looks
we
something
can
like
have
that.
a 100-sided regular figure with one angle. Wait, no, actually 100-sided irregular figure with one angle being 40.7296 degrees.
Okay. I don't know how that was relevant to whatever's going on right now, but cool. Cool stuff. We'll talk about the circle yet. So we have 5 points which are where every adjacent pair is 5 centimeters. And now we only have 4 colors, which means that some 2 of these are going to be of the same color. So that tells us that even if we color in 4 colors instead of, let's say, 2, say 4 colors, then we can, by looking at the pentagon, we'll be able to see that we have 2 points which are at a distance of 5 centimeters away. This is what Shivant was saying. I think Chinmay has a problem with this, but before we go to Chinmay, is
No,
everybody
I was understanding it like slightly different. It is right.
okay? it is right. Okay, awesome. So this is what Shivant was saying. Is everybody okay with this? Then is everybody okay with this?
Yes.
Okay. If people don't have anything to say or ask, you can lower your hand. Aitreya, Johan, do you guys have something to say?
Oh, no, I raise it as
Okay.
I actually found a slightly different proof for the two-color thing. Can
Okay,
I-
wait. We will go to it. Let's just focus on this. I think there is something wrong with whatever Shivan said. Can somebody point out what is wrong with it?
Yeah, ma'am, we would need six a hexagon because uh, अरे यार, why I'm understanding the problem wrong.
No worries. Naitik, do you want to help us out? Do you know what's wrong with this argument?
No, I don't really know what's wrong with the thing.
Okay, Akhil.
Ma'am, may I?
Yes, who was this? That's right.
Yes.
Go ahead.
Let's say we have four colors: red, blue, green, and yellow.
Okay.
Then we color, let's say, one point with red,
Okay.
and then we color another point with blue, the
Okay.
consecutive point, I mean, yeah. And then we can now color this point with red.
Right.
Then we can color the other point with blue,
Okay.
and then we can color the other point with yellow.
Right.
And then we do not have any problem because the diagonals not,
Exactly.
yeah.
So
No, ma'am. What I meant was like then you take any one point and make one more from it, like one more pentagon, and keep doing this until you have found all the pentagons. You'll get one pair like that in that.
Okay, so this was not mentioned in your presentation. But so what you're saying is we take a point and make another pentagon from it?
Yes, ma'am, and you do this with all the vertices you get from all the different pentagons you make, and finally you'll get it.
Will we? I'm not very sure.
Ma'am, can I annotate to tell what I'm telling?
Yeah, sure.
Ma'am, I didn't really understand this particular part.
Yeah, I'm also trying to understand what he.
This pentagon, this one.
Yeah. So what he's saying, so now let's say we have four colors. He's trying to generalize the argument for two colors to n colors. And he's saying he has to generalize it. And he's trying to explain that. So why don't we do one thing, Shivan? Why don't we take this up towards the end of the class? You
Okay,
can
ma'am.
wait behind. Yeah. Thank you. And Johan had another. You could quickly look through that. Yeah, Johan, please go ahead.
Okay, so let's just take a random point, point A, and then you make a circle around it, which is 5 centimeters, which has a radius of 5 centimeters. And then if you have any blue point, or let's say point A is blue, like the center point.
Okay.
And then
Okay.
if you have any point on that circle that you just drew, which is blue, then you're done. But if
Mhm.
all of them are red, then you still have like a chord of the circle, which is 5 centimeters long. So
Right. So what Johan said, I'll just quickly repeat. Let's consider a blue point. Now we draw a circle of radius 5 centimeters around it. Now consider any point on here. It's going to be a distance of 5 centimeters away from this middle
Yes.
point, right? Just by the definition of a circle. Which means that if this point is blue, then we're done. Yay! Because then we'd have 2 points which are at a distance of 5 centimeters
But what
from
if all
each
of
other.
them are red?
Huh?
But what if all the points in the circumference are all red? Then
Exactly. then let's say, so this that is exactly what. So every point on the circle is supposed to be red. So now I'm just going to tweak Johan's argument a little bit. Now consider a circle with center R and radius 5 again. So it's going to look something like this, right? Terrible circle drawing skills, but I hope you understand.
It's
Now,
like Venn diagram.
yeah, and now this point here is also red, and this point is also red, and they're 5 centimeters away from each other. So we're done. This is very similar to what we did before with the equilateral triangle. Just this can be slightly more of an intuitive construction for some people.
And
yeah.
ma'am, if
I also
we
got something.
know another solution, if all points are of same color, we can join the chords. Join the chord of 5 centimeters.
Yeah, this is exactly what Johan said. Yeah. But the thing is, then you'll have to argue why there should exist such a chord in the first place.
Yes, ma'am. That's right.
Yeah, Saket, what were you saying?
Ma'am, I understood this, but not the pentagon proof, ma'am. What is that?
Yeah, the pentagon proof. So we decided to take it up towards the end of this.
Oh, okay.
Okay.
Ma'am,
Let's
that
move
was
on to.
almost like this only. Just instead of
Mhm.
circle, we take the n+1 shape.
Interesting. Okay. I'm still not entirely. I still haven't understood it entirely, and I'm very interested in it. So we'll take it up towards the end. Okay. Now this is very interesting. So this is the same premise as what you were doing earlier. We are again coloring it in two colors, red and blue, let's say. Now we want to show that there exist 4 monochromatic points, which means 4 points the same color, and they form the vertices of a rectangle, something like this. So is the question clear? What it's saying is, no matter what coloring you give me, since I'm a magician, for now it's a magic trick because we don't know why it works. There will always be some 4 points which form the vertices of a rectangle and are of the same. Okay. So I hope the question is clear. If not, you can speak up right now. I'll wait a few seconds.
Ma'am, can you show the question?
Yeah. Okay. So let's keep this problem slightly aside for a while. And let's play a game, because why not? Who doesn't like games, right? Now, here's how the game is going to be. There are going to be 2 players, and both of them go alternately. Let's say I'm playing against who do I see on my screen? Let's say I'm playing against Nidhi. Then let's say we decide that I'm going first. So what I'm supposed to do is I'm supposed to write 3 letters, but each of them can either be A or B. So I can write, let's say, AAA, or I could write ABA, or I could also write BA, or I could write BAB. I just want to write 3 letters, but each of them has to be A or B. Then it's Nidhi's turn. Let's say I write ABB for us, just for now. Then it's Nidhi's turn, and Nidhi is supposed to write again the same thing. But there is a slight constraint here. Let's say Nidhi writes BAB. Now it's my turn again, so I have to write something again. So let's say I write AAA. Now it's Nidhi's turn again. So let's say Nidhi writes B, B, A. Now it's my turn again. Let's say, so you'll ask, when does this game even end, right? So the thing is, the game ends. I'll tell you when the game ends. So now let's say I write A, B, A. Now the game will end and I will lose. Why? Because of something I wrote, Nidhi was able to find a rectangle which had the same color, same letters at all of its vertices. So whatever I write, Nidhi should not be able to form a rectangle which have the same vertices, like A, right? So I lose. Is the game clear? Let's try playing the game a few times. But for now, is the game clear?
Yes, ma'am. Yes, ma'am.
So you can write any
A bit.
you can write any coloring and your opponent can write any other coloring, right?
Yeah,
There is
but
constraints.
yeah, there are no constraints. The
Okay.
only constraints are each letter should either be A or B.
Yeah. And when
And
they
that
form
is
a rectangle, that player wins.
yeah.
Okay.
Saket, is that a question? Saketaram, is that a question you have?
Yes. Oh wait, but no, it's fine. Like I'll understand when we play the game.
Okay, Naitik.
I'm a bit confused about the rectangle thing.
Right, let's try playing it. Do you want to go first or second?
I'll go second.
Okay, so let's say, okay, let me just title this here. I'll write down the rules so that you can write 3 letters, each of which is A or B. There are 2 players. Alternate. We write 3 letters each of which is A or B. Player who can form a monochromatic rectangle. Yes. Okay. In their turn, can
Ma'am, can I go?
find monochromatic rectangle in their turn. Okay. So Aithreya versus Naitik. So Naitik wants to go second. So Aithreya, you can go first. What do you want to play?
Ma'am, what? I'll take A A B.
AAB. Naitik, what do you want to play?
A B B then.
ABB. Okay, so are we able to find any rectangle here? Looks like not. Okay, so Aithreya, it's your turn to play.
ABA.
This is Aithreya, this is Naitik. Now what's Aithreya again? ABA. Are we able to find the rectangle anywhere? I don't think so. So it's Naitik.
I'll do all B.
BBB, that's a bold move.
No, he won. He won. He won. B.
How? Oh, he did not win. So actually, now since it's Aithreya's turn and we find a rectangle in Aithreya's turn, Aithreya wins. Right?
Oh.
Good catch, Saket. So now since we have a rectangle here,
But then
Aithreya
isn't
wins.
A blocking the? But I thought the rectangle has to have all the same letters.
Yeah. So this rectangle, yeah, B, the rectangle.
Oh, like the corners.
Yeah, the corners, yeah.
Oh, okay.
Yeah, just the vertices.
Ma'am, actually,
I've had
Ma'am, next can I play?
Ma'am, next can I go?
Wait, what did Akhil say?
Ma'am, may I have a turn?
Okay, sure. We'll play 3 more games at the max. Samrit, do you have a strategy or what? Why have you raised your hand?
No, ma'am. Sir, I was asking if I can play. No.
Okay. Okay. Wait 1 second. Rectangle with the same colored vertices. This is what I mean when I say
The same lettered vertices, I think.
a good catch. Okay. And I'm not sure if lettered is even a word, but anyways. Okay, now somebody who wants to play, raise your hand. People who want
Akhil.
to play. Yeah, Akhil, and who's the other player?
Who versus who?
Akhil and Shivansh. And then next time we'll have Samrit and Sak. Yeah, Akhil. You do want to go first or second?
Ma'am, I would like to go first.
Okay. Shivansh, are you fine with this? Or do you
Yes,
want to go first?
No,
Okay.
ma'am.
Yeah,
Ma'am,
Akhil, what do you want to play? Yeah,
Ma'am, BAA.
interesting.
Ma'am, I'll play A. AAB.
Interesting. Akhil. So other people, you guys can try and help out your friends. So now if somebody has an idea for what Akhil should play here, you can tell him that you should play this. And if Akhil agrees, he might even just play that.
Ma'am,
Excuse me, ma'am, can you repeat a specific pattern? I mean, can you repeat what the word you have used, the arrangement you have used twice?
Great question. What happens if Akhil writes BAA here?
Ma'am, then
We will obviously find a rectangle then.
yes, ma'am. We can find a
Exactly.
rectangle.
oh yeah.
If we
Ma'am,
repeat
but
something, sorry?
nothing, ma'am, right? Nothing.
Okay. So great questions coming up. These are definitely going to help us solve.
Ma'am,
Mm-hmm.
ABA.
ABA. Okay.
Ma'am, BAB.
This is getting tougher and tougher. Okay.
You can max go for 8 or less. Less than 8, it can go maximum. So it's gonna end.
Right. So Saket, great thinking. Now try to see if this you can relate this with the previous question that we just posed and did not work on it.
Oh,
Just try to think.
I get it. Huh? Right.
Okay.
Ma'am, ABB.
ABB.
BB.
Now what is Shivan's playing?
Ma'am, I play. Ma'am, BBA.
BBA. Okay. Okay, what do you want to play?
Ma'am, Ollie.
Ollie, are you sure?
Yes, ma'am.
Ma'am, I have a rectangle.
No, ma'am,
Can
no,
I-
ma'am, no, ma'am. Sorry. I
Okay, okay.
mistakenly said it. Sorry, ma'am. Ma'am, I cannot play anything.
You cannot play anything?
No, ma'am, wait. AB, no, I have played that, right? Now only 2 are remaining, right?
Mm-hmm.
And both are losing for me.
Right.
No.
Okay.
Ma'am, does BBB work? Because it does form a rectangle.
Ma'am, from that BAB,
Then a
the
rectangle
will be
Ma'am,
shown.
it is a rectangle.
Yeah,
Ma'am,
I see a lot of rectangles.
Ma'am, and there's one more too. Yes, that one.
Ma'am, AAA
here
forms a lot of a rectangle too.
Mm-hmm.
Ma'am,
That's
so
right. Okay. So this is a win for Shivan. Awesome. Good game, you guys.
Me versus Samrid.
Okay, and this is the last game we'll play, and then we'll try to analyze what's happening.
Ma'am, I found a strategy.
Okay,
Ma'am,
great. Keep it to yourself. Keep it to yourself.
we can generalize the problem. Means we
I'll
can
come
find
to you, Chinmay. I'll come to you, Chinmay.
Ma'am, make it M versus K because our first two letters are all same.
Oh yeah.
Okay.
K. Oh, okay.
Okay.
Oh, no. Wait.
Yeah.
Last. Okay.
Who wants to go first?
Saket, you can go first.
Okay, fine. I go A. Easy.
What a bold move to make. Okay. Samrit.
ABB.
Okay.
Okay. This is interesting. Definitely not going to go. Wait. Oh. BAB.
Okay.
I don't know, I lost it.
Akhil, in the meanwhile, do you have a question, Akhil?
BAB.
No, I'm by mistake, ma'am, for chance
Okay,
I
okay,
won
it's okay.
before.
BAB? Are you sure you want to do this, Samrit?
Yes, ma'am.
Oh, I won.
Really?
I won.
No, that's. How did you win?
Because he found a rectangle.
Ma'am, N is coming in his. So Saket.
Sorry?
Oh, I get the. Oh my god. I got the. Ma'am, I think
Do
I
you want to try
didn't
again? Do you want to try
understood
again?
the question yet.
Do you want to try again?
Ma'am, yeah. I thought the question. I thought that he can only find with the moves I have played. That's what I.
No.
Okay. Hmm. BBA.
Okay.
Is there any? Okay, there is no. O A B.
Actually, one thing, both of the players can't put two A's in their arrangement because then
I know.
Yeah, exactly.
Great observation.
Now
Because
knight
this
can be used to heal.
Oh,
Ma'am, any move Saket plays, he will lose.
oh
Right?
yeah, I will lose.
You can't use two A's nor you can use two B's. So it is done.
So like I can't put three A's, of course. I can't put two A's. I
Ma'am,
I can only put one A and two B's or all B's. All B's I cannot put because of course. Wait, all B, yeah, I can't put because I put BAB. Oh my god, my options all narrowed because of my own moves. Okay.
The first move you
I
played.
can put one A and two B's. Let me try.
no.
But in all positions. Okay, I lost. Killed by my own moves.
Great. Awesome. Good games. But now you'll ask me, okay, why are we doing this game thing? Like, why aren't we trying to do some math? Just do some actual studying and stuff? Why did we start playing this game? Well, cool. I'll answer your question. Don't fret. It's because we just solved this question. Oh my god, I'm mind blown. How did we solve this question by playing games? Any idea? Or am I just I think I'm getting people tell me I'm getting older, and so that's why I'm getting like a little crazy in the head. Is that what's happening here?
No, ma'am. Instead of the colors, we just used A and B.
Yeah, ma'am. So
Okay,
like
would you
this.
like to elaborate on that? Like, how did we end up proving this by playing this game?
Ma'am,
Yes.
if we do like the same we done in this,
Mm-hmm.
just we have to place A and B
Mm-hmm.
color red and blue
Mm-hmm.
against O and B, and we will definitely get an rectangle after some steps.
How do you know that? Like, how do you know the game can't go forever?
Ma'am, because there would be only 2 raised to power 3 moves.
Okay. Can somebody else who is not Shivansh, Akhil, Chinmay, Saket, Nidhi, people who are not these people in the list I mentioned, I want somebody to explain what just happened here.
Ma'am, may I explain?
Samridh, yes, okay.
Ma'am, so what happens is there are only a limited moves you can do.
Why is that?
Ma'am, because you can't repeat 2 moves again. Just like the question about last question. If you repeat 2 moves,
Exactly.
if we take the perspective of this game, if we repeat 2 moves, then it will form a rectangle no matter what.
Right. Why?
And
Because
because there are only a particular number of combinations of A and B.
exactly. So we only have finitely many moves we can play without repeating. In fact, we can use simple multiplication principle ideas that we've been seeing in the previous sessions to find that it's actually at most 8. We can have 8 such combinations ranging from AAA, AAB, ABA, BAA. Then we'll have BBA, BAB, ABB, and BBB. These are the 8 combinations that we have. So we have at most 8. And so after 8, obviously we're going to have a rectangle. So replacing letters with colors, we'll be able to see that, okay, we have to have a rectangle with monochromatic vertices. So a nice homework problem can be to write down this proof, because it can be tricky to write it down mathematically. So write down the proof of the question 2. Let me just say question 2 in a mathematical manner. It's a very good exercise.
I have a question.
Yes.
What do you mean by mathematical manner?
Great. So you can't just say that, okay, you can't just say, hey, okay, let's keep this question aside for a while and let's play this game. And while playing this game, we see this. Now replace this with this. This is not very formal. So I think if you go back to
So like with variables.
2 sessions.
So
Sorry?
it's like a equation we have to say.
Not necessarily, but it just has to be rigorous, more something that you could write in a math exam.
Okay.
Yeah, great question. Okay. Okay. Anything else? Okay. Shall we move on? So since we're already talking about games here, I thought why not play some more games? How many of you have heard of NIM games? Raise your hand if you've heard of NIM games.
Which game, ma'am?
Especially outdoor games.
Not outdoor games.
What was the name of the game?
Nim, N-I-M, Nim.
It is a combinatorial game, right?
Yeah. So I just wanted to know how many you are. Okay, great. Now that's what we do. So, if you already know the strategy to this, then I would like to give you some separate problem to work on. So okay. So the first problem the first game that you're going to be solving is, let's see this. Again, it's a two-player game. Sorry?
What is NIM?
Ah, yeah, that's what you're going to see. I have no clue if NIM is a short form for something or what, I don't know. So this is the first game we're going to be playing. It's one of my most favorite games. Again, we have two players.
Ma'am, if you flip the name, it will become Min. And today, that AGMNC, that exam, I attended, and there was a problem. What is the number of money Min had?
Okay, interesting theories coming up. We'll keep that aside for a while. So here's how the first game really is. Again, we have two players. Again, they alternate. We have a pile of 10 stones. You all can lower your hands if you have things. Lower your hands. Then we have, let's say, a pile of 10 stones. Right? Or let's actually make it harder. Just why not? Let's make it some big number. 361.
50.
Okay. And in each move, the player can remove either 1 or 2 or 3 stones from the pile. And when does this game stop? When all the stones are gone. So the game, when a player cannot make a move, they lose. Mwahahaha. What does this mean? This means that the last player, the player who picks up the last stone, wins. So now what you want to do is, what is the question here? You will say, okay, the question is, obviously you want to win. So I see Shivan, one second, Shivan and Johan raising hands, so I'll give them an alternate game to work on. So here, let's say the second game is going to be, do you also know the 2-pile version of this?
Ma'am, I knew the 2-pile and 3-pile, not the 1-pile version.
Okay, fine. Then you can work on the 1-pile. Sorry?
And there was a similar game till 21 which I played with my school, and then I introduced a mathematical way to cheat, and everybody was wondering how I won all the time.
Okay. We'll see if we can find a strategy for that. So people have raised hands. Johan, why have you raised your hand? Shivansh, why have you raised your hand? Akhil, why have you raised your hand? Yeah, Shivansh, go ahead.
Ma'am, so like you have to make your own pile which is bigger than the other one, or just have to like reduce the pile of 50 stone?
Yeah, it doesn't matter how many stones. Let me finish, and then ask. Yeah, no worries. So you only win when you take it doesn't matter how many stones you've removed. That does not matter. What matters is that you remove the last one. So that the other player has nothing to do and they lose. Ha.
Thank you.
Akhil.
Ma'am, I did not understand, like, if there are two piles of 10 stones.
Wait. So, do you understand the 1-pile question?
Yes, ma'am.
Have you solved it?
Ma'am, I did not understand it. Like,
okay, don't go to 2 piles. 2 piles is not something you're doing right now.
ma'am, it's
Just
only
focus on
one pile of 50 stones.
Yeah.
And the player has to remove from up or down? From up, right?
It doesn't matter. Just Just remove the stones.
Okay, ma'am. Okay.
Ma'am,
Yes.
this is something related to the game Uno.
Is it?
Yes.
Uno is something that is
Yeah.
much more complicated.
Yeah, but you just have to finish now. The same like aim in both of the game.
Okay, sure.
This is related to which game?
Uno.
No, it's not that
kind of.
related to Uno, but sure, she's saying the aim of both the games was the same. So they seem similar. Even in Uno, you have to finish all your cards, and here also you want to finish all of them. Akhil, do you still have a question?
No, I forgot to raise the lower hand.
Awesome, awesome, no worries. So now, okay, somebody who did not get to play a game earlier, instead of having like 50 stone pile, we'll make it a 20 stone pile and play the game. Anybody wants to play? Somebody who did not play earlier.
Ma'am,
Ma'am,
may I?
Yeah, Darshraj, sure, Darshraj and Raga. And then after that, Aitreya. So Darshraj
Ma'am.
versus Raga.
Actually, for 20, it becomes a lot easier.
Does it? Interesting.
Yeah, this strategy changes.
Oh, okay.
So I will go second.
So you already know the strategy, is it?
No, I just thought of it right now.
You just thought of it. Okay, I would prefer somebody who hasn't come up with the strategy yet.
Okay, fine.
Yeah, sorry, yes. So who was this Raga versus who was the other person?
Aitreya.
Ma'am, Chinmay. Ma'am,
Chinmay.
Aitreya.
Okay. Aitreya. Okay, fine.
But
Aitreya, I'll come to you. Sorry?
She, I guess, played the last game.
Yeah, okay. So we'll have Raga and Chinmay. And then Aitreya can play on the next one if she wants. Who wants to go first? Do you guys have any preference as to if you want to go first or not?
Ma'am, I will go first.
Okay, awesome. We have 20 stones initially. Ding ding ding. Chinmay, how many do you want to remove? 1, 2, or 3?
Ma'am, 3.
3. So Chinmay removes 3. Ding ding ding, and we have 17 remaining. Okay, Raga's turn. Raga, how many do you want to remove?
2.
Raga removes 2. Ding ding ding, and we have 15 remaining. Chinmay,
Ma'am, 3.
you remove 3 again. Okay. And we have ding ding ding, 12 remaining.
I'll
Raga.
remove 1.
Interesting. So we have ding ding ding, 11 remaining. I think I would make a really good game show host. Okay, go on. Chinmay.
Ma'am, I would remove 3.
Okay. So we have ding ding ding, 8 remaining. Raga.
I'll remove 3.
3 again. Huh, game getting more and more interesting. We have only 5 stones remaining. What will Chinmay do?
Ma'am, Chinmay can win the game. Ma'am, I will remove 1. Yeah.
Chinmay removes 1.
Yeah, that's what I was thinking.
Okay.
I guess doesn't matter if I remove 3 or 1. I mean 3.
Right. Okay. So whatever Raga admits her defeat, and she has won. Chinmay won. This is great. Okay.
Ma'am, okay, may I play one time?
So this is taking a while to play. So I'm thinking we'll just try to get a strategy from here. So when Chinmay reached 4, we immediately knew that he won, right?
How did Chinmay win?
Chinmay won because Chinmay said 4, and now no matter what Raga does, let's say Raga removes 1, then Chinmay can just remove the remaining 3. He wins. Let's say Raga removes 2, then Chinmay can remove the remaining 2. He wins. If
Is the
Raga
rule that the person who picks the person who picks the last one loses, or person who can't do a move anymore loses?
the person who cannot make a move, they lose. Which means that the
Okay.
player who picks up the last one, they win.
Okay, thank you.
Awesome. So let's try to be smarter, and let's not play games. I think it's taking quite a while. So we immediately knew when he reached 4. So when C reached 4, it was as good as reaching 0, right? Because no matter what R does, C is going to win. Make sense? So now our new goal is to reach 4. If we reach 4, we win, right? Okay, let's think about this for a while and let's see if we're able to come up with something. So how can we reach 4 now?
Ma'am, I have a strategy. Can I tell?
No, let's wait for more people to think.
Ma'am,
Mm-hmm.
I think if we reach 6, we can reach 4.
Okay, so if we reach 6, then no. So let me clarify here. What do I mean by reaching 4? It means that I remove something from the pile and there are 4 remaining.
Oh,
Then I'll win, right?
yes.
So let me clarify this. So what does this mean? Yeah, Samrit, what do you have to say?
Actually, I have played this game before.
Okay.
It's like a game of 21. You start from 0 and go till 21, like the opposite. But I also derived the formula that
Okay,
we
then
let
wait. Don't give it away. So I think some people already know this, right? So okay. I'll give you guys another question to work on in the meanwhile. Other people think about this. Now we want to reach 4. How will we reach 4? So it's the same way as reaching 2, right? If you remove something and there are 0 remaining, we win. Same way, if we remove something and there are 4 remaining, we win. So try to think more about this. In the meanwhile, I'll just give a problem to whoever solve this one. So yeah, I think I'll ask you what you have. But okay. So this is again, I'm going to introduce a grid. We have a rectangular grid. Let's say it has, let's say, 9 and let's say this was 9 and let's say this was 100. And there's this is very beautiful grid. Assume it's a grid. You start here. And again, there are 2 players. So let's people who have already done all these things, please listen to this problem. So you start at top right of the rectangular grid. Let me type this one again. So start at the top right of the rectangular grid. Again, it's the same thing, alternate moves. In a move, what can a player do? In a move, player can move anywhere to the right. So move. Okay, let's start. Move anywhere to the left or anywhere to anywhere downwards. Person who reaches bottom left corner wins. Since we can't make a move after that. This is the question. Try and
Ma'am?
find the strategy.
Ma'am,
Hmm?
I have moved how to reach to the 4.
Yeah, wait. I see people raise hands. I'll ask them. Great. That's exactly the way you should be thinking, and Chinmay. Very good. Yeah, Naitik. What did you have to say?
I think if one player always plays like one less, like if one player played 3, then the other player will play 2. So player B plays 2, and if this keeps on going on, that player B plays one less than player A, then I think player B should be able to win.
Great. Anybody wants to go against Naitik? Does anybody here wants to go against Naitik? Naitik is saying he'll always win when he's player 2. Let's play a quick game. Yeah, Samrit, would you like to go against Naitik? Okay, Samrit is not here. Okay, awesome. Samrit, go first. How many do you want to remove? Quick.
-3.
-3. Okay. So Naitik is going to do?
-2.
Awesome. So we have 17. Naitik does -2. We have 15. Now? Quick.
Yeah. -3.
-3 again? Okay. Interesting.
I'll
Suspicious.
do -2 again.
Obviously. Okay. 10. We have 10. Samrit.
-2.
-2 again. So we have 8. Naitik.
-1.
-1. So we have 7. Naitik, can you guess what Samrit's next move is going to be? Okay.
-3.
-3. And Samrit has reached 4. And now Samrit has won the card.
Actually, he planned the whole thing. The
Oh
first
my
time
goodness.
he actually
Samrit,
messed it
wait. Don't give anything away. Samrit is so evil. He planned this entire defeat of Naitik. I'm so sorry, Naitik. Okay, think more.
Ma'am, can I play the next round?
No. Now we're not playing. Now we're just thinking more. The reason I asked, if only if you're very sure that you have a strategy, then you can go. You can tell me what your strategy is. We'll discuss, and then if it
Yeah.
seems right, we'll
Ma'am, I
play.
have a sure
Ma'am,
strategy.
Ma'am, can you move to the
Eight,
next
we can
question
win.
once? I'll just take a
If we reach to the
screenshot.
8, we can win.
Great. Okay, so Chinmay is giving us another support. Chinmay is saying if we reach 8, we win.
Yes,
Great.
ma'am, you can move.
Somebody? Yeah, thank you. Can somebody tell me why is Chinmay saying what he's saying? Like any clue at all?
Ma'am, can I?
Advance, yes. Go ahead.
Ma'am, so like basically, if you reach 8, it is just the case like you subtract 4 from both sides. Like from 4, you subtract 4 to get it on 0. So, like if you come on 4, you win.
Mm-hmm.
So basically, you keep 4 as the 0 point and change all the others likewise. So you get 8 as the next 4, and
Okay,
you keep
that's
doing that.
Okay, wait. Just pause there. Pause there. You've said some very, very, very good things. I just want to make sure people are understanding and following. Okay, somebody else who is not Shivan, somebody who is not Chinmay, somebody who is not Samrit, somebody who doesn't know the strategy from before, want them to explain why in the world will reaching 8 guarantee us a win. Any idea at all?
Ma'am,
Who is this?
Aitareya.
Aitareya, yes, tell me.
It's a multiple of 4.
So,
So maybe it can guarantee us a win.
wow, maybe? I don't deal with maybes, okay? I'm very competitive. And when it comes to games, I have to always win, no matter what the other player is doing.
Uh,
Yes, Naitik. Oh, Ahan. I haven't heard Ahan's voice. Ahan, please.
So,
Yeah.
ma'am, say
Mhm.
now it's your opponent's turn. The opponent can either play 1, 2, or 3. We saw the case
Exactly.
where the opponent played 1, like in this game. But if they say the opponent plays 2, so then if the opponent plays 2, then we have 6. So what our aim will be to for the opponent to play, right? So then we'll have 2, so 6. Then we play 2, which is
Mhm.
we get to 4, and then we automatically win. Or similarly,
Right.
if when we are on 8, the opponent plays 3, then we are on 5, we play 1, and we automatically win.
Exactly. So what is Ahan? What are Samrit, Ahan, Chinmay, and all these people? Naitik, what are they saying? They are saying that the opponent can only play 1, 2, or 3. So, like, no matter how hard the opponent tries to reach 4, they're not going to be able to do that, right? Like, just do whatever you want. You'll never be able to reach 4. The lowest you can go is 5, maybe, but you can't go any lower than that. So, no matter what your opponent can do, you can just make it so that you reach 4. So, let's say opponent say they play 1, then you can reach 4. Then you remove 3 and reach 4 and win. Yay, party. If they play 2, say they play 2, then you remove 2 and reach 4 and win. Party again. And say the last case is when they play 3, see they play 3, then you remove 2. Then you remove 1 and reach 4 and win. Let's go. Good job. So reaching 8 guarantees us a win. Damn, nice. But can we go one step further? What more can we say from here? Okay, reaching 8 guarantees us a win, but okay, so we were originally at 0 and we increased that number to 4. Now we've increased it to 8. Can we go even further?
Yes, ma'am.
Yeah, go ahead. Shant.
Ma'am, we can take 12 next and then like all the multiples of 4 till the final number.
Exactly. So similarly, again, reaching 12 is going to guarantee us a win. So again, we can say, okay, reaching 12 is very lucky for us. So again, when I earlier remember when I said write down this mathematically, this is not mathematical. So this is not what I mean. I'm just writing this, so it's fine. Yes, reaching 12 is very lucky for us. Why? Because again, the same argument applies. The opponent can play only 1, 2, or 3. So no matter how hard the opponent tries, they can never reach 8. But no matter what the opponent does, we can reach 8 from 12. Right? So similarly, after 12, we can extend. Similarly, 16 is also winning.
Ma'am,
Which means
So-
if we reach 16, we win.
So, ma'am, that means like say whenever whoever starts first is on the losing side, because say
Exactly.
20, so
Ma'am,
then
I
we
think
minus
in this
whatever number
problem,
you can reach
the
16.
second player
Chinmay, wait, wasn't he talking? Wasn't Ahan talking? So let Ahan finish and then you speak, right?
So that
Ahan,
means, like,
please, can
so
you?
we have
Mhm.
so whoever plays second is basically bound to win if they play in a proper manner, because if they have 20, then we can then the person they want, they can reduce to 16, which can be reduced to 12, to 8, to 4, and then win.
Right, exactly. So even before the game starts, if the second player is smart enough, the first player is destined to lose. No matter what the first player does, he can never win. Chinmay, what were you going to say?
Sir, ma'am, I was just saying that.
Okay, great. Good job. Very good job to all of you who called us. I'm very happy. The first player, no matter what he does, is destined to lose. If both the players are, no matter how smart the first player is, if the second player knows his strategy, first player loses. So if you ever come across this game, then always be the second player if you're starting with 20. Now there's multiple variations that we can try of this game. Okay, let me just look at what Samrit, you have raised your hand. Do you have? Is it from before? Okay, Chinmay, you've raised your hand. Naitik?
The thing is, the strategy will vary depending on the number of stones you have at the start, right?
Great point. That is exactly what I was coming to. Wow, people can read my minds now. Okay, so let's say we had 50 stones in the beginning. Then what would the strategy be? Would you want to be the first player or the second player?
First player.
First, okay, interesting. I'll let people think about this for a while. Oh, Amit, would you like to unmute and explain? Oh, the first player can only win on one condition if it's their birthday. Ha ha ha. Okay. So for 50 stones, Amit, think about what you do for 50 stones. Would you want to be the first player or the second one? If you want to win, assuming. Then it's not the opponent's birthday.
Ma'am,
Mm-hmm.
First
tell
player.
what
Ma'am, we
I-
want to be the first player,
which
right?
player I would be? I would be the first one.
Oh, so many people want to be the first player this time. Okay. Interesting. Just one person. Yeah, and what would your strategy be?
Ma'am, can I explain, Ahan?
Ma'am, 2. I would start from 2.
Great. Ahan, did you have something else to say?
No, I had the same answer.
Awesome. Okay. So I want people, and really encourage people who don't see where this is coming from to think by yourself and try to come up with this. Why would you want to remove two? How will removing two guarantee you a win? It's very easy to see. I'm sure you'll see it if you are not able to see it right now.
Can I say, Ahan?
Sure. Go ahead.
So, ma'am, like same. So we saw that if you manage to reach any multiple of 4, you're bound to win. So
Exactly.
the closest multiple, which is less than 50 of 4, is 48. So our aim should
Right.
be reaching to 48, which if we are the first player, we can easily achieve.
Awesome. Great. I couldn't have explained it better. Great. So great job, Chinmayahan, Shivans, and everybody. Okay. Who solved this problem. I don't think I can take everybody's name, but I'm very happy with all of you who worked on this and solved it. Now there are so many extensions that we can get for this, right? For example, I can make this 1 or 2 or 3 or 4 or 5 or 6 or 7 and make this number 1579. Then what would you do? Or, okay, maybe if that's easy, what if I make this in each move the player can either remove 1 or 3 or 5? Then what would your strategy be? Or let's say in each move, the player can either remove 2 or 9 or 11. Just some random numbers. There's a lot of extensions that you can think about. Is there even
1, 4, or 9.
Hey, I'm just throwing random numbers.
Ma'am, say if it's true. So we'll just take our aim would be to get to a multiple of a number which is greater than the highest number. So in this case, 4. If the highest number is 11, then 12. Or
I really urge you to think about it because that might not always work. When we skip numbers, like when we look at, let's say, 1, 2, and 9, say, you can't just look at multiples of 10. You cannot. Why not? I want you to think about that. Because now the problem changes a lot and things get trickier and slipperier. And I think
I think I have a strategy.
for
For like if you have any you can have any amount of stones and any amount of options to like remove stones. First, you have the thing is once you reach a multiple of 4, depending on what the other guy or girl removes, you have to remove an amount of stones so that the amount the first person removed plus your amount will be a multiple of 4 or a multiple of 4. So that's it.
But it's great. This was a strategy for this game, right?
Yeah, but I think it might also work if the things weren't 1, 2, 3. Maybe if it was something else, I think it will still work.
Would it now or would it not? You never know. So I want you to try this game for, let's say, 1, 2, 3, or 4. Or even if it's just, let's say, make it easier. Try it for 1 or 2. What if it's just 1 or 2? Would it work? So let me write this also as a homework. Where should I write this? I think possibly I should probably work on my whiteboarding skills. Okay. Homework, more homework for everybody. Fun, yay. Possible extensions of game 1. It's also known as a NIM game. Possible extensions of game 1 above. So what can we change? One thing we can change is change the number of initial stones, or we can change the rules or the number of stones that we can remove. So some examples if you want to try is, okay, one example could be can remove 1 or 2, or can remove 1 or 2 or 3 or 4, or can remove, let's say, 1 or 3 or 5, or let's say can remove 1 or let's say 1 or 7 or 9, etc., etc. Just be more creative, be as creative as you can be. Another crazy extension I just thought of is increase the number of players. Ha 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 ha. Then can we have something?
Ma'am, when you increase the number of players, it actually gets hard.
It actually gets hard, yeah. Definitely something to think about. Any other extensions you guys any other extensions that I might have missed?
Ma'am, we can increase the number of players and decrease the number of stones that we can remove. Like only 2 options. 4
Yeah.
and 9.
Sure. So
Ma'am,
that
we can do like that the people can remove any number of stones, just that they have to finish the game in a particular number of moves.
wow, okay. How
Then the
would
first
that
player
work?
will remove every stone,
Yeah.
all these stones, and then game over.
No, so for that, like, we have a particular number of moves in which you have to complete the whole pile.
So won't it just be that if the number of moves is even, then one player wins, and another number of moves is odd, then okay. It's definitely something to think about. Okay.
What if there are a n number of players, and then in one round, they finish all the stones? How many possibilities are there?
Oh, now that's a counting question. Okay, let me write that. It can remove any number of stones, but constraints on the number of moves.
Ma'am, so like here the number of stones to be removed can be negative also. So that will mean you are adding some stones in that pile again.
But
Like,
I don't understand very clearly.
like you can't continuously remove like in some particular number of moves. You will need to add some stones as well. So like the number will be keep changing.
Ma'am, but I have a way
Okay.
where you can, actually finish the last condition. So, like, say if we have, say if we
Which
have
condition?
the, like the one which, just you said, you can remove any number of stones you want, but
Mm-hmm.
you have limited moves. So, say if I have 50 stones and,
Mm-hmm.
say 3 moves,
Mm-hmm.
so then we can just take like minus 2 from 50, which is 48, and then which is divisible by 2. So just like, because 50 is not divisible by 3, we just deduct some number to it where it will be where we can divide the number by a number smaller to it.
These are some interesting ideas. I'm not sure if they were, but definitely something to think about. So if you guys do solve any of those questions, do write to me and I'd be like more than happy to see what solutions you come up with. So wait, yeah. And we'll just quickly summarize and finish this. And if you guys want to discuss more about this, you can stay back. I'm here for another 10 minutes. So, but for can adding stones, I'm not sure how that would work because we have no incentive to add stones. Our goal is to remove all the stuff. But okay, awesome. So let's summarize what did together. Zoom out, zoom out, zoom out. There we go. So we started out with this nice problem where no matter how you color the plane, you will always have 2 points which are even. Do you see how you can? This is not just for a 5 cent. This argument can also be generalized to any number of centimeters. You could write square root of 2 here and it would still work. You could write some weird number, right? Like 3 raised to 1 point, blah, 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 minus blah, 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 plus. As long as it's positive, it's still going to work. This argument still holds, right? Which I think is very cool. No matter what distance you give me, I'll always be able to find 2 points which are that distance away and are monochromatic. Then we saw, okay, then we said, okay, no matter how we color the plane, there exists 4 monochromatic points which form the vertices of a rectangle. So here we had any 2 points which are some particular distance away. Now we have they should form a rectangle, the vertices of a rectangle. And then we said, okay, let's keep it aside for a while. We had this very cool game which was fun. And then we saw that, oh, this game is actually, it was just a ploy to get you to solve this question. So, and then we solved the question using that. And we saw the most fundamental in game so far. Where we had 2 players, we can remove some number of stones, 1 pile. Yeah, it's something that we missed here is what if we have more piles? So if we have more than 1 pile, yeah. Right? Okay. And then wait, let me have to write this down. It's also a very standard one. We have more than 1 pile, and in any move, the twist here is, and in a move, you can remove any number of stones, but only from 1 pile. So let's say we have 2 piles.
And suppose you take infinity stones.
How will that work? Our goal is to remove all the stones. It doesn't make sense.
Yeah.
Okay.
What if we take all the
Uh-huh.
stones in a particular pile?
Then the second player can just take all the stones in the other pile and win. Because we have two piles. It's very interesting. So for those of you who are interested, I would highly encourage you to try this problem.
Mom, for the
Yeah?
last question, I already have a way to
Okay,
get
then I'll give you a harder one. I'll give you a harder one. And in a move, you can remove any number of stones, but only from one pile. Or you can remove equal number of stones from both piles.
What if you take a number?
If there's a 50 and 50 piles, you can just remove 50 from both piles and you win, right?
Yeah, but what if you have 50 and 100?
Ma'am,
Ma'am, I have two ideas. One idea.
We won't be discussing the ideas here. So if you're still very much interested in doing this, but I think you have a WhatsApp group, I think you have a Google Classroom, just put up a message there. Hey, I want to discuss this game problem. I want to see how it solves. It's very interesting. Does anybody else want to? Well, let me finish. Does anybody else want to do this with me? Let's meet up. Let's have a Zoom link. Let's have a Google Meet link. And make new friends, guys. See, this is how I made friends when I was a student from math classes. So, funny story. I'll just finish this here. I'll stop the recording, and people who want to listen to my funny story can stop and listen. It's not much.